What if I told you that one of the most beautiful and complex images ever created comes from a number that mathematicians once thought was completely impossible? Today, we're going to unlock a hidden universe. And believe it or not, it all starts with one single, really elegant idea.
Okay, let's dive right into what I like to call the secret art of math. You know, we usually think of math as super rigid, all logic, a world of pure reason. But what we're about to see is that it also holds this secret world of just breathtaking, almost unbelievable artistry.
Take a look at this. Now, this isn't a picture from a satellite or something you'd see under a microscope. This is called the Mandelbrot set. And here's the truly mind-bending part. If you were to zoom in on any of those chaotic, fuzzy-looking edges, you'd find perfect little copies of the whole shape just repeating over and over forever. So where in the world does this infinite detail come from? Yeah, that is the big mystery we're going to solve today. It seems totally impossible that a simple mathematical process could generate this level of artistic complexity. To figure it out, we have to go way back in time to a problem that stumped some of the greatest minds for centuries. So, to unlock that amazing image, we first have to tackle what was thought to be an impossible problem. The entire secret is actually hidden inside a very, very simple equation that for hundreds of years seemed to have no solution. Here it is. X squared equals -1. All it's asking is to find a number, we'll call it x, that when you multiply it by itself, you get -1. It sounds easy enough, right? But think about it for a second. I mean, if you try a positive number, like 2, you get 2 times 2, which is +4. Okay, what about a negative number, like -2? Well, -2 times -2 is also +4. For a really long time, this was just a dead end. There was no real number that could possibly work. So what do you do when you hit an impossible problem? Well, if you're a mathematician, you do something kind of brilliant. Instead of giving up on finding the number, you just decide to invent it. They literally imagined a new number into existence. They came up with a new symbol, I, and they gave it one simple property. When you square it, you get -1. That's it. That's the whole rule. It's like adding a brand new piece to the chessboard of math. And this one tiny definition, it changes everything. Now, this is super important. Don't let the name imaginary fool you. It's not a make-believe number. A better way to think of it is that it opens up a whole new dimension. We used to just have a single number line, right? You could go forwards or backwards. But now we have a new direction to move in. So what happens when you combine our old, familiar real numbers with this new imaginary one? Well, you get something called a complex number. And as you can see right here, it has two parts, a real part, like the number 5, and an imaginary part, like 2i. But how do you even visualize a number that has two different parts? Well, if you've got two parts, you need two directions. And this is how we start to map out the complex plane, which is the very world where the Mandelbrot set lives. So instead of that single number line, we now have a full-on two-dimensional map. We call it the complex plane. The horizontal line, the one going side to side, that's for all the real numbers we already know. And the vertical line? You guessed it, that's our new dimension, the imaginary axis. So now a number like -2 plus 3i is no longer just some abstract idea. It's a specific location on the map. You just go -2 on the real axis and then up 3 on the imaginary axis. And boom, you've just plotted a single point that represents that entire complex number. It's just like a city map where every house has a unique address. Well, every single complex number has its own unique spot on this plane. We finally have a way to see this entire universe of new numbers. And now, finally, we can connect everything back to that mysterious, beautiful piece of art from the beginning. We've got our new numbers and we've got our map. Let's put them together. Get ready for this. That stunning image of the Mandelbrot set is the complex plane. Every single pixel in that image corresponds to one of those complex numbers we just figured out how to map. The entire image is just a visual representation of how those numbers behave. So how do they behave? Well, they follow one incredibly simple rule. You take a number on the plane, z, you square it, and then you add the original number you started with, c. Then you take that result and you do the exact same thing again, and again, and again, forever. The black parts of the image, those are all the numbers that stay calm and don't fly off to infinity. The colored parts are the numbers that do escape, and the color just tells you how fast they do it. That's it. That simple repetition creates all of this insane complexity.
So let's just recap this wild journey. We started with an impossible problem, squaring a number to get a negative. That led to the invention of I. This new number allowed us to create complex numbers, which have both real and imaginary parts. Then we realized these numbers could be mapped onto a two-dimensional plane. And finally, we saw that applying a very simple rule over and over on this plane is what generates the infinite and beautiful complexity of the Mandelbrot set.
You know, this whole thing started just because someone dared to imagine a number that couldn't exist. It really makes you wonder, if inventing just one new rule for math can unlock a hidden universe with this much depth and beauty, what other incredible worlds are out there, just waiting for us to make one more imaginative leap?